Guys, let us see a few more problems on formulation of PDE. We have done one problem earlier. Now let us see a second one. To frame a PDE or to form a PDE by eliminating the arbitrary constants. The first method only. So the given equation here is z is equals to xy plus xy plus y times under root of x square minus a square. Okay, so plus b. There are two arbitrary constants, guys. Okay, so we first step as usual differentiate partially with respect to x and y. Okay, so when we differentiate partially with respect to x and y, what do we get? Let us see the first step with respect to x, dou z by dou x. Look at this is a function of two variables x and y. So we got to be very careful here. When we are differentiating partially with respect to x, we treat y as constant. So y is as it is. Derivative of x with respect to x is 1 plus y is as it is. Derivative of under root of x square minus a square is 1 by 2 times root of x square minus a square into derivative of internal part, the chain rule what we say for the normal differentiation. So it's going to be 2x, derivative of x square is 2x, but the derivative of a square is a constant, so it's going to be 0 plus, anyways b is a constant, it's 0. Okay, so this is how you get. Now simplify this. What is this in the standard form? This is p. So p is equals to y plus, you can cut these two basically. So you can take out a y in this case if I am not wrong. Otherwise you can keep y however you prefer to be. Okay, so you can keep if you want, or you can cut it if you doesn't want. Right. So let that be there. So we say y 2x, y into 2x we can write directly as 2xy divided by under root 2 into under root of x square minus a square. Cut 2 here, let y go that side, we get p minus y, therefore is equal to xy divided by under root of x square minus a square. Okay, so keep it as it is. Now let us differentiate partially with respect to y. This equation partially with respect to y, z will be partially differentiated with respect to y, therefore it will be dou z by dou y is equal to, once again there is a product of two functions, we are differentiating with respect to y, we treat x as constant, x will be as it is, derivative of y with respect to y is 1 plus the entire x term is going to be considered as a constant, let it be there, derivative of y with respect to y is 1 plus the derivative of constant b is 0. Okay, so now what we have, applying the standard terms here, we have q is equal to x plus under root of x square minus a square. Otherwise we can rearrange it, q minus x is equals to under root of x square minus a square. You can see the same term is here, so let us go substitute this here. Therefore we have p minus y is equal to xy divided by under root of x square minus a square, which is equals to, instead of under root of x square minus a square, we can write q minus x. Now this goes the other way, so we get p minus y into q minus x is equals to xy, and we no more have the two constants a and b, hence we can say that this is the required partial differential equation. Understood, guys? So this is how you can frame a PDE for the given equation. Let us see a problem where we got to analyze it and then frame it. Alright? How does the question look like? Let me see that. Let me show you that. Okay, the question says find the PDE of the family of all spheres, okay, where centers lie on the plane z equals to 0. So their centers lie on the plane z is 0 and have a constant radius r. This is the constant radius. So let us see how do we solve this. How is that the PDE going to look like? Okay. So in general, we are considering a sphere. Sphere is a three-dimensional figure. So every three-dimensional point, a point in a three dimensions is usually represented by the help of coordinate triad, that is x, y, z. Alright, we have three coordinates here, x, y as well as z. But now we are speaking about a point which is lying on the plane z is 0. On the plane z is 0, we have every z coordinate value will be 0. Hence, the point on the z plane z is 0, which will be in the form of x comma y comma 0. Okay, we can assume x value, that is x coordinate is a, an arbitrary constant, and y coordinate is b, again an arbitrary constant. Here you can write, let a comma b are arbitrary constants. Okay, so this is a general point which lies on the plane z is equals to 0. Okay, now our center, let us assume this is the center. It's an arbitrary point and hence we have the two arbitrary constants. Okay, the centers lie on the plane z is 0. So let this be a point of center and we have the constant radius. What is the radius? Radius is r. Now we got to frame the equation of the sphere. How does the sphere look like? Then what is the standard equation of a sphere? Equation of sphere with center C given by AB 0 and radius R is given by, the equation will be in the form of x minus a the whole square plus y minus the y coordinate, that is b the whole square, plus z minus 0, that is the z coordinates whole square, is equals to the radius square, which is r square. This is the standard equation of the sphere. Let us simplify here. Z minus 0 is z. So we get x minus a the whole square plus y minus b the whole square plus z square is equals to r square. And as r is supposed to be treated as a constant, they are given there clearly. R, it has a constant radius. So r is a general constant, but it is not an arbitrary constant. So how many arbitrary constants we have in this equation? Only two, that is a and b. We got to get rid of these two constants, then only we can frame a PDE. How do we get rid of the two constants? Again by partially differentiating. So let us differentiate partially this equation. Partially with respect to, again, both x and y. Okay, so what happens with respect to x first case? With respect to x treating y as constant, derivative of x minus a the whole square will be in the form of x square, right? Derivative of x square is 2x, same here, but we have to apply chain rule. 2 times of x minus a into derivative of x minus a is 1 plus this entire term is independent of x. Therefore, the partial derivative of y with respect to x is supposed to be treated as 0 because y is a constant here while differentiating with respect to x. And now, derivative of z square will be 2z into dou z by dou x. Why dou z by dou x? Chain rule, but with respect to x and as z is a function of two variables here, it is instead of d we are supposed to use dou. Okay, is equal to r is a constant, hence derivative of r square which is going to be 0 as well. Alright, and we know what is this term equal to? Dou z by dou x is nothing but the standard form p. So we have 2 into x minus a plus 2zp is equals to 0. Okay, so we can simplify this if you want and then find what is zp. So zp therefore is equals to, this goes here, minus 2 times of x minus a divided by 2. 2 gets cut. So we get minus of x minus a. Otherwise, z x minus a can be taken as, because we can substitute here directly. So we can take it as minus z. Similarly, when we differentiate partially with respect to y, treating x as constant, this entire term is going to be 0 and this will be 2 times of y minus b plus derivative of z square with respect to y will be 2z dou z by dou y and derivative of r square will be 0 because r is a constant. Understood? So going ahead in the same way, what are we going to get? Let us see what we get. So we get here, simplify this, we get again in the similar way, this is q, dou z by dou y is q. So 2 times of y minus b plus 2zq is equals to 0. Simplifying in the same way, we get y minus b is equal to minus zq. This is minus zp and this term is minus zq. Let us go ahead and substitute these two in this equation. So this equation has two arbitrary constants a and b. When we substitute these two, the two arbitrary constants can be easily eliminated and hence we get the required partial differential equation. Therefore, we can name this equation 1 becomes, so applying these two values here, we get minus zp the whole square instead of x minus a the whole square. Similarly, y minus b is replaced by minus zq the whole square for this one, and then for z square it is as it is equals to r square. Simplify ahead, you get a z square common in every single term. Take out the z square, we get p square plus q square plus 1 is equals to r square. So z square is taken down. Therefore, z square into p square plus q square plus 1 is equals to r square is the will be the required differential equation, which a partial differential equation which represents the family of all the spheres, whose centers are on the plane y equal to 0 and they have a constant radius r. What are p and q here? P and q are the standard partial derivatives with respect to x and y respectively. Understood?